All right, we're on page 2 of the study guide. Let's take a quick peek. This number 2 says decide whether each of the following is linear or not linear. In each case, explain how you know. So let's go over here. First of all, if I can try to move things around and make this look into one of the forms of my linear equation, then that will help me. So what if I subtract 2 from both sides of this equation? All right, if I subtracted 2, that would leave me 3x plus 4y is equal to -2. Now I recognize this as the standard form of an equation. This can be manipulated to look like the standard form of a linear equation. Also, I see that the x is a plain x to the power of invisible 1. I know that all plain x's to the power of invisible 1 are linear. You could put a couple reasons. You could also say if I graphed this function, it would be a line. You could show the graph of this function that it is a line. On this next one, anytime you're given a table, you're going to go ahead and show what is happening from jump to jump. So for right here, from 1 to 5, this is going up by plus 4. From a 5 to a 15, this is going up by plus 10. From a 15 to a 30, this is going up by plus 15. So upon initial inspection of the right-hand column, or the change in y, this is looking like it's not constant, but we always have to check the left-hand column, the change in x, to see if it does come out constant. Let's check this out. So this is a change of up 2. The next jump is a change of up 2. And the final jump is a change of up 2. So the change in y over the change in x, that's what gives us our slope, our constant rate. So let's see what we have here. We have a 4 over 2 for the first one. It simplifies down to a 2. We have a 10 over 2 for the second one, which simplifies down to 5. For our last one, we have a 15 over 2, which simplifies down to a decimal. Since these are not constant, they do not come out to the same slope to the same change in y over the same change in x, we will say this is not linear because it does not have a constant rate. Notice the work that I show to prove that it was not linear. You have a secret that you tell to one person. Every hour, each of the people that know the secret tell one person. The number of people who knows is n, and t is the number of hours since you told the first person. Is n a linear function of t? All right, so you have a secret. And so for the number of hours, number of people who know. So at time 0, you are the only person who knows the secret. So one person knows the secret. So in the first hour, they tell one more person. So now we know that 2 people know. In the next hour, those 2 people each tell one person. So 2 more people know, which now means that 4 people know. Those 4 people tell each one person. So now 8 people know. Those 8 people each tell one person. So those original 8 plus the new 8. So now 16 people know. Those 16 people each tell one new person. So now 32 people know. And those 32 people each tell one person. So now 64 people know. Notice from 1 to 2, 2 to 4, 4 to 8, 8 to 16, that each of these jumps, because they're each telling one new person, it's doubling. This is not a linear function because the number of people who know is doubling each time. This is a geometric sequence because it is multiplying by 2 each time to the previous term. So this means that it would be an exponential function, not a linear. Now, all you had to say was that it was not linear because the number of people you know is doubling. It is not a constant rate, it's a common ratio. So something along the lines of it not being linear and y is all that you had to say. Whether it's exponential and all those other things, that comes next unit. If you already knew that about the exponential part, even better for next unit. Number 3, water freezes at 0 degrees Celsius and 32 degrees Fahrenheit. Water boils at 100 degrees Celsius and 212 Fahrenheit. Write a degree Celsius as a linear function of the degrees Fahrenheit. So we're going to look at this first as those two sets of information they gave us are two xy coordinates. So I know that 0, 32 is my first pair of coordinates, and that 100 to 12 is my second xy pair. What that means is that they're giving me Celsius, Fahrenheit as my xy coordinates. So my function of Celsius, x. But this wants write degrees Celsius as a linear function of degrees Fahrenheit. So here we go. So Celsius, first I need slope formula in order to calculate the slope for this. Right, so our slope formula goes y2 minus y1 over x2 minus x1. So we're going to plug in the 212 minus 32 divided by 100 minus 0. So we get 180 over 100, which reduces down to 18 tenths, which reduces down to 9/5. That's our slope. So now that we have a slope and we have an x1 and a y1, we can say y equals, and by the way, we're going to use c and f. So f equals 9/5 c minus 32. And this is in y equals mx plus b form. Where we plugged in our slope of m, we plugged in our b of 32. How do I know that's a b? How is this the y-intercept? Because 0, 32, for the y-intercept, the x is 0. So here's my function write the degrees Celsius as a linear function of degrees Fahrenheit. What is the slope of your linear equation and what does it mean? The slope of our linear equation is 9/5. This means that for every 9 degrees Fahrenheit, it is 5 degrees Celsius. Because 9, or the numerator stands for our Fahrenheit, our change in Y, and the denominator stands for our Celsius. What is the Y-intercept and what does this mean? The Y-intercept is 0.32, and this means that at 0 degrees Celsius, it would be 32 degrees Fahrenheit. Write the equation of the line represented by the following table. So again, we need to get the change in Y over the change in X. Notice that your X is only going up by 1 each time, so that's nice. So on this side, it's going up by 100, 100, 100, 100. So change in Y over the change in X is the same as Y2 minus Y1 over X2 minus X1 and this is going to give us our slope in order to write the equation. So 200, well, I don't mind using the later numbers so that we get a nice no negative denominator. So let's go 500 minus 400 over 1 minus 0. This equals 100 over 1, or just 100. The equation of a line, you can use any xy pair from over here. So for example, if I wanted to just say y equals 100x plus 400, this is me just using the slope and the y-intercept in mx plus b form. But let's say you didn't notice that y-intercept. You could go y minus any y pair. I'm going to use 500 and 1, and slope of 100, x minus 1. You can use any x, y coordinate pair. This would be if I used the coordinate pair of 1, 500. If I distributed this down, 100x minus 100, added the 500, it would still equal and simplify to this.